Well, we've been solving for some areas of composite objects and stuff. You could say that surface area is kind of a composite object type of a thing. It's just that they're not in a plane. It's you got to wrap your head around this three-dimensional object and try to figure out, well, what are all the areas that I have to find the area of in order to get the total surface area. So we start with a Bricky object. So we got this ingot type thing. We want to find the surface area. So think about how many faces we have. We have the top face, hiding is the bottom face, this side, and then this face, and hiding back there is the other face. That's 1, 2, 3, 4, 5, 6. There are 6 areas that we must find. So let's kind of get started here. So I guess actually the top, call this the top right here. The top might be the easiest to find because it's a rectangle, and you can see that it's 3 inches this way, and you can see that it's 12 inches this way. So the area of the top is 3 times 12 equals 36, and you should probably put your units just to be safe. 36 square inches. 1 down, 5 to go. Okay, bottom. What's the dimensions of the bottom? So you have to imagine that there's this rectangle on the bottom here, and the dimensions would be 5 inches this way, and it would be 12 inches this way. And then I can remove all this marks I'm making on my beautiful ingot. But anyway, it's 5 times 12, which is 60 square inches. 2 down, 4 to go. I want to deal with this trapezoid right now. Why? Because it's a trapezoid. We have formulas for trapezoid, right? The area of a trapezoid is, do you remember we would define it sort of like, well, you can use whatever letters you want, but this side was A, this side was B, and then you had a certain height, a straight up height. And what we said is it would be, the area would be, you take the average of A and B, A plus B over 2, and multiply it by the height. That's the area of a trapezoid. You could look that up on your paper if you had forgotten it. The A and the B, we got those. So this top edge is 3 inches, and this bottom edge is 5 inches. That's my A and my B. And then the tricky part is we got to get the H. Oh, we don't. That's not tricky. They told us. Look at that. Look, I'm smearing it, but it's there. 2 inches, and that's a straight up. That's what we need. Remember, you need a perpendicular height. Height must be perpendicular in all these things. And that's measured straight up. It's 2 inches high. Oh my gosh, we're flying, man. So you work this out. 3 plus 5 is 8. Well, the 2's cancel really. So it's 8 square inches. Yep, 8 square inches. And then there's 2 of those. So I'll just write 2 of those. And then I'll say the what do I want to call these? The end caps. I'm going to call them the end caps, and I'm using plural because I mean both of them. There's 8 square inches for each trapezoid, so that's 16 square inches total. That's the end caps. Okay, cool. We're getting somewhere. We are boogieing now. Okay, so now what? Well, now I'm going to switch colors because we're going to do something a little more involved. We got to figure out the area of this rectangle. Now, I know what you're thinking. It's a rectangle. What could be hard? I'm going to call this what? Right face or something. Right face. It is a rectangle, and it's going to be 12 inches. That is that dimension. And now we need this dimension. And then you go, wait a minute. That's not 2 inches. That's not 2 inches. This is 2 inches straight up, right? So now we're going to have to figure out, well, if that's 2 inches, I'm going to use a little s. What's the slant height here? And if we assume symmetry, and I think we can because it's an ingot, right? Ingots are symmetrical kinds of things. If it's 3 on top and it's 5 on the bottom, that's kind of like saying that we squeeze in an inch on this side and we squeeze in an inch on this side, right? 5, take away 1, we get just a 3. So we can just kind of reason that this must be a 1 inch here. That's a 1 inch. So what's S then? Well, Pythag theorem to the rescue. C squared equals A squared plus B squared. Remember all this kind of stuff? And if you work this out real quick, 1 squared is 1, 2 squared is 4, 1 plus 4 is 5. You take the square root. So the slant height, I'll write it up here as well, is actually the square root of 5. And I'll just work with the square root of 5. So it's 12 square roots of 5 square inches. And I think we can assume it's the same, right? Because we are assuming symmetrical. So wait a minute, 2 of those. 2 of those. So it's actually 24 square roots of 5 square inches. So let me make sure that looks really good like a 24. Underline that one. I'm just going to put each. So I got to add these numbers. The top is this, the bottom is this. Both of the end caps together add up to this, and both of the, what do you want to call them, the side thingies, these. Both of those slanted surfaces add up to 24 square roots of 5. So now we can get the total. I'm ready for a new color. So I'm going to go like this. Okay, total surface area. 36 plus 60 plus 16 plus 24 square roots of 5. And at this point, you probably want to get out your calculator and get some kind of decimal going, right? You kind of want a number. You don't want to say, hey man, square root of 5. What? Okay, so 36 plus 60 plus 16 plus 24 radical 5 equals 165. And it depends how many decimal places you want. Maybe 1 is good. 165.7 if I go to 1 decimal place. Now, did it ask for square inches? It just said find the surface area, so we get to use whatever area we want. So there we are, 165 square inches. Recall, 1 square foot is how many square inches? Do you remember? Or can you re-figure it out? Remember, the way you think of this is a square foot measures 1 foot on each side, right? If you measure in inches instead, you're measuring 12 inches on each side, and so that area is 144. And so if you divide that 165.7 by 144, you can get square feet. It'd be about 1.15 square feet. So I am going to have you do some unit conversions in your homework, so make sure you're happy enough doing those and keep your unit conversion table happy, or not happy, handy. And happy. Keep it happy and handy. Anyway, so when it comes to Bricky objects, it's a bunch of rectangles, and you might have to do a little trig or Pythag or something to get some of the slant dimensions and so on. Ooh, I see a 60-degree angle. That makes me think that trig might be involved here. But maybe not. Let's just find out. It says find the total surface area of this leaning tower of Pisa. Well, we got basically a circle here, and it looks like the same size circle here. And then we're going to have to worry about this slanty part. We'll worry about that last. First, let's get the circles. They're the easy part. So area circle is, well, you can use different formulas. I like this one, pi d squared over 4, especially when they give you the diameter. So they gave us the diameter of 8. Pi times 8 squared over 4. So if you work that out, I think you get 16 times pi. 64 divided by 4 is 16, right? Yep. 16 times pi each circle. So the area of the circles is 32 pi, and that would be square centimeters. You want to think about what units you've got here, right? So I didn't write them in my equation, but they are centimeters, and they're being squared. And so my units are definitely square centimeters. Okay, cool. So just kind of hold on to that for now. Erase some of this goop I just put on there. I don't like too much goop on my solutions. Okay, now I'm going to worry about this slant height. So the area of the slanty part, well, kind of think of it as some kind of a weird soup can. And it's got like this wrapping paper or this label around it, right? How big is that label is the question. Well, if you unwrap it, can you kind of see how the circumference of this circle is going to be 1 dimensions of that piece of paper once you unwrap it and lay it flat? Because it has to wrap all the way around here exactly once. So whatever that dimension is, that's going to be one of your dimensions of your paper. So I'm not saying that it unwraps as a rectangle, but this is going to have to be, remember, circumference is pi times d. That's supposed to be a d. Make it a d. D. Circumference is pi times d, and so that's one of the dimensions. And then, I always have to think about what dimension do I use here. And actually, because sometimes I get tempted to use like a perpendicular height, because I'm always talking about perpendicular heights. But not here, because we're talking about this soup can. The paper really does have to be 10 centimeters wide in order to fit on this can. So you would use the 10 centimeters here. And so this area would be, you've got your 10 centimeters, maybe I'll put the units this time, and then you'd want to go pi times, where'd you go? All right, then you'd want to go pi times the diameter of that thing, which is 8 centimeters. And so we've got basically 80 pi. And notice that is centimeters squared because we've got centimeters here and we're multiplying by centimeters here. So it is square centimeters again. So maybe I'll put that in a box, and I'll put this other thing over here in a box. Now I put this apostrophe S here on purpose to say both circles 32 pi, the label 80 pi, and so the total area, surface area, sometimes I use SA to stand for surface area, is you take your 32 pi and you add your 80 pi and you get your 112 pi, and this is called square centimeters. And maybe we'll get a decimal out of that. What do you say? 112 times, and I got a nice pi button here, and it says, like, if I keep a few decimal places here, it's like 351.86 square centimeters. That would be the answer if all they said was find the area. That's all they said, find the area. If all it says is find the area, well, you should put your units down so people say 351, huh? 351 what? You got to tell them the area, so make sure you put your square centimeters on your homework and stuff. Here's a little exercise for you. Let's do a purple. No, wait, but hey, purple. Let's do a purple exercise. Convert to square inches. I'll just let you pause and try it. Unpause and watch. Okay, so we've got 351.86 square centimeters, and you have to remember, of course, an inch is 2.54 centimeters. You have to either remember that or go look it up on your chart, right? An inch is 2.54 centimeters, and please remember that centimeters squared do not cancel centimeters. No, they don't. A centimeter is not a square centimeter. They're different. A centimeter measures along a straight line. A square centimeter is measuring tiles that are about that big. Well, not really, but so what you got to do is you got to say, well, I need to cancel centimeters squared, so what I'll do is I'll take this whole thing and square it, right? And maybe it'd be easier if instead of writing it that way, I said, well, 1 squared, that becomes inch squared. 2.54 squared, that becomes square centimeters. And now the square centimeters cancel. So anyway, you're taking your 351.86 and you're dividing it by, a 2.54 squared. Squared! That's the big thing, folks. 2.54 squared. Okay, so I said it enough. Now you've got it burned in, right? And that equals just about 54.5-ish. 54.5, and as long as I'm carrying 5 sig figs, I might as well continue to carry 5 sig figs. There's a decimal there. That's how many square inches it would be. Okay, cool. So you know about slanted cones and things. Okay, here's a cone, and there's a pyramid, come to think of it. But here's a cone. Now I'm going to give you a formula for the cone. So first of all, that's a circle, right? So let's say we have a certain... Oh, let me look at something before I make a mishtuk. Yeah. Let's say we know the radius. Okay, and then, fine, we know the radius. So the area of the base here, the circle part, is going to be, well, you could use pi r squared. You could use pi d fourth over 4 if you wanted to. But there, that takes care of the circle. But the area of the slanty part is what? And I'm just going to say it happens to be pi r times s, where s is the slant height. Not the height straight up, but the actual slant height along the slant, that height. And you just got to kind of know that. Pi rs is the slant height. You can play around with like pieces of paper, make them into cones, unwrap them, and try to come at this formula. That's how I make sense of these formulas. But we don't need to do that right now. Just trust me. If you need the full surface area of the cone, you're going to need this formula to get the slanty part, and then you're going to need, of course, don't forget the base down there, the pi r squared circle part. Now, what about a pyramid? Well, this is a nice question. Let's see now here. The pyramid has a square base measuring 10 feet by 10 feet. So that would be the base. The base, that's easy. The area of the base, it's a square measuring 10 feet by 10 feet. So the base is 100 square feet. Okay. Now we just got these other sides, these triangle sides. Now there's 4 of them. And it looks symmetrical to me. So we'll say each triangle. I'm going to lay that triangle out over here, lay it flat, and because this is 10 feet, we know that this is 10 feet, right? Those two sides correspond. Now here's the thing, I need the area of that triangle. Got to be careful with this part. Pyramid shape is a square base measuring 10 feet by 10 feet, yep, and it's 10 feet tall. The pyramid is 10 feet tall. Notice what that does not mean. It does not mean that these are 10s. It does not mean that. These are not equilateral triangles. The only way they'd be equilateral triangles is if all the sides were the same, but they're not saying that the slant heights are 10. They're saying the height of the pyramid. Now when they say that, they really do mean straight up through the middle here. You have to picture like a perpendicular right in the middle of that base there. That's the height. That's 10 feet. That's 10 feet. Right through the middle, that's 10 feet. Okay, so what the heck is this then? I'm going to call it the slant height. Yes, I am. I'm going to call it the slant height. So we got to try to solve for well, let's see. Where's the slant height on this thing? The slant height would be, I guess, the same as this edge here, right? That's the slant height that we're trying to solve for. Wait a minute. Do I want the slant height? I might not even want the slant height, because I could do this, right? Area of a triangle is 1/2 times the base times the height, where the height is measured perpendicular to the base. So really, I don't want that slant height there. No. I want right through the middle of this thing, right there. See, so this I'll call S, which would be the same as this, and it would not be the same as this. In fact, I should probably give it another name just to stop confusing things. Let's just call that dimension X. Okay, I'm trying to get that X there, which is the height of the triangle. It's measured along the surface of the pyramid right through the middle of one of its sides. Now the H they gave us, and it's 10 feet, so maybe I'll erase the H and put 10 feet there. That's 10 feet. And, well, we might as well join this to this. So if it's 10 feet all the way across, that must be 5 feet, right? So now we can just use Pythag to get at that X then. So this X squared is the same as 5 squared plus 10 squared. So you finish your Pythag thing here. So 5 squared plus 10 squared equals, take the square root of the answer equals, expressed as a decimal, we're getting X equals 11.180. And these would be feet. Okay, cool. So now we're rocking here. So the area of that triangle is 1/2 times the base is 10 times the height is 11.180. Cool. And that's basically 5 times 11.180. And that comes out to 55.902. And these are all feet that we're plugging in, so this would be square feet then. So the area of a triangle is 55.902 square feet. I got 4 of those, so I'm just going to write 4 of those is, and you take your answer times 4, boom, 223.61. Add the base, so the base was 100.00, and so the total area here is 323.61 square foot. There's our answer right there. So let me come back up, make sure I'm answering the question. That's all it says. Find the total surface area. So square feet's going to be good enough, I guess. Yeah, so make sure you're getting, make sure when you're looking at squares and triangles and things that you're very careful about what really is the dimension of this triangle. We knew it was 10 feet across the bottom because that's 10 feet across the bottom, right? But this is not 10 feet. I don't know what it is. We could solve for it now if we wanted to, but the 10 feet was up through the middle. That was the key point. The height of the pyramid is measured straight up from the table, which in this case is right straight up from the middle of the square, straight up to the roof. And so then you have to kind of look inside the pyramid and try to figure out, well, give me a dimension that has something to do with my triangle over here, and this dimension worked for us, this x. This dimension helped us get the area. So yeah, be careful when you're digging around these 3D shapes. Make sure you get the right dimension for the task at hand. What else we got here? Spheres? Is this the last one? This is the last one. Spheres! Let's play with the sphere for a little bit. So the surface area of a sphere is just a formula you got to know. It's 4 pi r squared. So yes, using the r, the radius. 4 pi r squared gives you the surface area of a sphere. We're going to use that a little bit down here in example 4. It says find the surface area of this R2D2 type shape. By the way, why do we want surface areas? Well, maybe you're going to paint this R2D2 shape. You got to know how much paint you need. Or maybe, what else? Maybe you're going to cover it in sheet metal. You need to know how much sheet metal you need. Or maybe you're going to drop it in a potion. You need to know how fast the reaction's going to go, because the reaction will go according to surface area. There's different reasons to know the surface area. But anyway, let's just find this one. That was just kind of an afterthought. Let's just find this thing. Now, this is meant to be R2D. This is like a three-dimensional shape, right? So this is kind of like, if I tried, the bottom is like, really it's a circle, and then the top, it's kind of like something like this, right? It's kind of, something like that. Some kind of R2D2 shape. So, surface area, huh? Well, a lot of times what you do with these problems is you divide them into, kind of like we did in the composite area in the plane homework. You just kind of break things up into shapes that you know about. So we can break this up into 3 shapes. Don't forget, we got a circle on the bottom. And then wrapping around the cylinder is going to be a soup label. I just like to call it a soup label. And then we've got this, it's not a sphere, it's a hemisphere, it's a half sphere. Hemispherical cap. So there's 3 shapes to worry about here. The hemispherical cap, the soup label, and the circle on the bottom. And you just kind of get one at a time. Maybe I'll call this A, give me a pencil. Yeah, I'll call this A, B, and C. So, get out some blue ink. A, circle on the bottom. Well, you can use the old pi d squared over 4 trick, because they gave us the diameter. Might as well just use that formula. So you go pi. The diameter is 2 foot. That gets squared, divided by 4. By the way, 2 squared is 4, so it'll cancel the 4, and you get just pi feet squared. So that's for the circle on the bottom. Maybe I'll write that answer here. Pi square feet. Cool. Might as well move on to B, the soup label. That would be this part. So picture yourself unwrapping that soup label. You'd get yourself a nice big rectangle, right? This would be the circumference of the circle, right? Because you need to wrap around the circle. So this would be the circumference. So you could say 2 pi r, or you could say pi times d. That's a circumference. Maybe I'll say c equals pi times d, which is, the d is 2 feet, so it's 2 pi, and that would be feet. That's that dimension. And now we need this dimension, basically how tall is this soup label. Notice it's not 5 feet. It's not 5 feet. The soup label only goes up to here. So what do we do then? We have to somehow back up. We have to back off the dimensions, so to speak. We have to figure out, well, how tall is this? I'll call this an h or whatever. Well, it's supposed to be, it looks like a nice flush fit here, right? So the hemisphere is fitting onto the cylinder nice and flush-like, right? So do we know the radius of this hemisphere? Because that would be nice. By the way, the radius, you could point the radius any way you wanted to, right? It would go from the middle to any point on the surface of the hemisphere. So I kind of drew too many radii there. But what is the radius of that thing? Can you tell? We can tell. Because of this dimension down here. 2 feet all the way across. Well, that's the same dimension up here, 2 feet all the way across. And if it's 2 feet all the way across, the radius must be 1 foot, right? Halfway across must be 1 foot. And it's 1 foot from there to there. It's 1 foot from there to there. And so if it's 1 foot from there to there and it's 5 feet all the way up, this has to be 4 feet. It has no choice. So this is 4 feet. So the area of the soup label is, take the 4 feet this way times the 2 pi this way, you get 8 pi. 8 pi, and we know that's square feet. And actually I can write that right here, 8 pi square feet. Cool. We're getting somewhere. What's next? Next would be the hemispherical cap on top, right? So this is part C, the hemispherical cap on top. So we got to go back to that formula we just got, right? The surface area of a sphere is 4 pi r squared. So I'm going to write that down. Spheres, 4 pi r squared. And so if we're talking about just halfway around, half a sphere would be 2 pi r squared. Now that's just counting the rounded part. It's not counting the part underneath. You know, a hemisphere technically would have a circle shape on the bottom, but we don't have to worry about that because that's inside the R2-D2. It doesn't expose itself to the environment at all. We just need the 2 pi r squared. And so the r is 1, by the way. So boy, that worked. And so we've got, go back to blue, I guess. We've got 2 pi times 1 foot squared. And so that comes out to 2 pi square feet. So we can come back up to here and we say the hemispherical cap is 2 pi square foot. And now when we add the total area up, you just got to add, pi plus 8 pi plus 2 pi. That would be 11 pi. Total surface area, 11 pi square foot. Let's get a decimal. You gotta wonder what the decimal is. 11 times shift pi, boom. It's about 34 point, if I carry a lot of decimal places just for fun, 34.558 square feet. Boy, that's a big, well, yeah, I suppose you're covering some square feet there. Okay, cool. Good. So we got our surface area formula, we got our soup label formula, we got our circle formula that we saw in previous lessons. We got our, be careful with pyramid type stuff. We got a formula for the slant of a cone, the area of the slanty part of a cone there, the pointy part, I guess. And slanted cylinders, that's good. And there's always bricks and trapezoids and things. Okay, so I hope you feel like you could have at that surface area homework now.